Welcome back, everybody. You ready to go on another deep dive?
Always. Where are we headed today?
This time, we're setting our sights on Ceres.
Ceres, the king of the asteroid belt.
Exactly. Specifically, we'll be looking at a couple of Wikipedia articles, Ceres, dwarf planet, and geology of Ceres.
Sounds like a plan.
Now, when you think of asteroids, you probably picture, well, rocks. Lots of them. But Ceres, it's in a league of its own.
Oh yeah, it's a whopper.
Over 900 kilometers in diameter. Can you believe that?
That's huge. I mean, that's like a quarter the size of our moon.
Right. For something in the asteroid belt, that's just massive.
And that size, it kind of gives it some unique features.
Like what?
Well, for starters, it's round. Not perfectly round, mind you, but nearly so. Gravity's pulled it into that shape. It's actually one of the key things that makes it a dwarf planet.
Makes sense. The bigger something is, the stronger its gravity.
Exactly. But what's even more fascinating is what it's made of.
Yeah, which under the hood of this dwarf planet.
So, based on its density, we know it's not just rock. It's got a whole lot of ice mixed in there, too.
Ice. That's pretty unexpected.
Right. You wouldn't think of the asteroid belt as a particularly icy place.
Makes you wonder where all that ice came from.
That's one of the big mysteries.
So how do scientists explain it?
Well, the leading theory is that Ceres didn't actually form where it is now. It probably formed much further out in the solar system.
Further out, like near Jupiter or Saturn.
Exactly. Back then, things were a lot colder out there, so water ice was much more common. Then, over time, it migrated inward to where it is now in the asteroid belt.
So it's like a time capsule, carrying a record of conditions from a different part of the solar system.
I like that, a time capsule. And speaking of records, if you look at the surface of Ceres, you can see all these craters.
From impacts, right.
Yep, but here's the thing. It's not as heavily cratered as you might expect for something its age.
What does that tell us?
It tells us that something have been resurfacing and reshaping parts of Ceres. It's not just a static relic from the early solar system. It's a world with a dynamic past and perhaps even a dynamic present.
Dynamic. Speaking of dynamic, what about those cryovolcanoes?
You're talking about those icy eruptions. One stands out, Ahuna Mons.
Right, that towering mountain, kind of lonely out there on the surface.
Yep, and its shape, along with its features, strongly suggests it was formed by those icy eruptions.
Fascinating stuff. And then there are those bright spots. They really caught everyone's eye in the early pictures.
Oh, yeah, those. The Dawn mission found out that they're actually deposits of salts. Sodium carbonate and ammonium chloride, to be specific.
Salt. So not just ice, but salt, too.
Yep, Ceres sure seems to be holding on to a lot of secrets about its past.
It makes you wonder, what do those salt deposits tell us about its history?
Well, one thing they tell us is that Ceres definitely had a watery past.
How so?
Those salts are probably remnants of ancient brines. They would have risen to the surface and then evaporated, leaving the salt behind.
So a watery past. That raises a pretty big question. Could there be a reservoir of salty water still hanging out beneath the surface?
A hidden ocean on a dwarf planet. It's a tantalizing thought, isn't it?
It really is. But how could liquid water exist so far from the sun? Wouldn't it be frozen solid?
Well, it's not getting tidal heating like we see on some of those icy moons out near Jupiter and Saturn, but it does have its own internal heat, the kind that comes from radioactive elements decaying in its core. And that might be just enough to keep some of that water beneath the surface in a liquid state.
So even though it's small and far from the sun, Ceres might still be hiding liquid water. That's pretty exciting.
You bet it is, especially when you consider what that could mean for the possibility of life.
So we've been talking about a subsurface ocean. Do we have any evidence to back that up?
There are a few things that point in that direction.
Like what?
Well, for one, we found hydrated minerals on the surface. That tells us there was definitely water around at some point.
Okay, that makes sense.
And then there's the evidence of past cryovolcanic activity.
Right, those icy eruptions.
Exactly. Plus those salt deposits we were just talking about. They all hint at a water-rich history. But there's more. The Dawn mission collected data on Ceres' gravity field, and it suggests that Ceres is partially differentiated.
Differentiate, what does that mean?
Basically, it means that Ceres isn't just a big homogeneous lump. It's got layers, kind of like Earth has its crust, mantle, and core.
Oh, I see. So what are the layers like on Ceres?
Well, the data suggests it's got a rocky, dusty crust, followed by a layer that's a mix of rock, ice, and salts. And deeper down, well, that's where things get really interesting.
How so?
That's where we might find a liquid or at least semi-liquid layer of briny water.
So the idea of a subsurface ocean isn't just speculation. There's actual scientific data to support it. Pretty cool.
It is, and there's another piece of evidence that could make things even more interesting.
What's that?
They've actually found organic molecules on Ceres.
No way. Where?
The Dawn spacecraft found them in Ernuchuk Crater. It's up in the northern hemisphere.
Okay, but what kind of organic molecules are we talking about here? And why is it such a big deal?
They seem to be aliphatic hydrocarbons, chains of carbon and hydrogen atoms.
Right. And those are important
Because organic molecules are the building blocks of life as we know it.
So we've got potential liquid water, internal heat, and now organic molecules.
It seems like Ceres is checking all the boxes for habitability.
It's true. While it's still a bit early to definitively say that life exists or ever existed on Ceres, the fact that all those key ingredients are there makes it a pretty exciting place to study.
It's remarkable. This seemingly insignificant object in the asteroid belt is turning out to be way more complex than anyone imagined, and potentially even habitable. Who would have thought?
It really challenges our assumptions about what's possible out there, and it highlights the fact that even the smallest of worlds can hold incredible surprises. Yeah, it's like our whole view of the asteroid belt is changing. It's not just a bunch of rocks anymore. There are some really interesting worlds out there.
Absolutely. And Ceres, with that crazy mix of stuff it's made of and all those unique features, it really gives us a window into how the early solar system was shaped.
You know those bright, salty areas we were talking about? Those kind of blew my mind. Do they tell us anything about what's going on deep down inside Ceres?
Well, the fact that we see those specific salts, especially together like that, it suggests they came from deep down, not just surface ice, more like from brines that froze and then sublimated.
So like the water in the brine evaporates and leaves the salt behind, making those shiny deposits.
Exactly. It's not just about them looking cool. It's like their chemical fingerprints telling us about what's going on way down below.
So combine that with the gravity measurements and those possible cryovolcanoes, it really starts to look like there could be an ocean down there.
It's incredible to think that something as small as Ceres out there in the asteroid belt might have more water than all the fresh water on Earth combined.
It really makes you rethink where we might find water and maybe even life in our solar system.
The more we explore, the more we realize that water, that key ingredient for life, could be a lot more common than we thought.
So let's talk about habitability. What are the big things we need for life, and does Ceres have them?
The big three are liquid water, an energy source, and the right chemical ingredients. And Ceres seems to have at least some of them.
We've already talked about that possible subsurface ocean, so that's the water part. But what about energy? Does it have enough internal heat to keep things going and maybe even support life?
Well, it generates heat from radioactive decay in its core. It's not as strong as the tidal heating you see on those moons around Jupiter and Saturn, but it might be enough to keep water liquid beneath the surface.
So water and energy check. But what about those chemical building blocks for life? What's Ceres made of?
The Dawn mission gave us a ton of data about its surface composition. We know it's got a lot of carbon-bearing compounds, including those organic molecules we talked about, the aliphatic hydrocarbons.
And it also has those hydrated minerals, right?
Exactly, those minerals with water molecules trapped inside them. So we've got carbon, hydrogen, oxygen, the basics for life as we know it.
That's amazing. Have we found any other elements essential for life, like phosphorus or sulfur?
Not yet, at least not on the surface, but they could be there in trace amounts, or maybe deeper down.
So it seems like Ceres meets a lot of the requirements for habitability, but are there any challenges for life out there?
Well, one big one is the lack of sunlight. It's so far from the sun that it gets way less solar energy than Earth. If there is life there, it would have to survive in a cold, dark environment.
So no plants then?
Probably not. It would have to be something like the extremophiles we see on Earth, those organisms that can survive in super harsh conditions and get energy from chemical reactions instead of sunlight.
It's amazing how life finds a way, even in the most extreme places.
Absolutely. Another challenge is the atmosphere, or rather, the lack of one. Ceres has a super thin atmosphere, so it doesn't offer much protection from the sun's radiation or cosmic rays.
So life on Ceres would have to be pretty tough to survive.
Tough indeed. But even with these challenges, the fact that Ceres might be habitable is pretty mind-blowing.
It really makes you realize that what we thought we knew about the solar system, maybe we don't know as much as we thought we did.
Right, and it's not just about the possibility of life. The surface of Ceres tells a fascinating story about its history and how it's evolved.
We've talked about the craters and those bright spots, but what about those really long canyons? What can they tell us?
Those are really interesting. They're super long, hundreds of kilometers, and pretty straight, which makes us think they formed from some kind of tectonic activity.
So like plate tectonics, like we have on Earth.
Not exactly like that.
Uh,
Ceres doesn't have plates that move around, but these canyons could have formed as the planet cooled and contracted, causing the crust to crack.
like wrinkles on a shrinking apple.
Exactly. It's like the crust was stretching and then snapping as Ceres lost heat.
So those canyons might be evidence of how Ceres has changed over billions of years as it's cooled down.
That's one possibility. Another is that they were caused by impacts, like a shock wave from an impact creating fractures in the crust.
It seems like every time we learn something new about Ceres, it just raises more questions.
That's the beauty of science. Figuring out how Ceres evolved is crucial to understanding its role in the bigger picture of how our solar system formed.
So zooming out a bit, how did Ceres change over time from when it first formed to what we see today?
Based on what Dawn told us, it looks like Ceres was a pretty active place early on. It was warmer from its recent formation, it had a ton of water ice, and there was probably lots of cryovolcanic activity, resurfacing events, and maybe even a global ocean.
Wow, so early Ceres was a totally different world from what we see now.
Yep, much more dynamic. Then, over billions of years, it cooled down, and all that activity slowed way down. Cryovolcanoes went quiet, resurfacing happened less often, and that ocean, if it existed, froze over.
But we still see some hints of activity, like those bright spots and Ahuna Mons. Does that mean Ceres is still changing, even a little bit?
You're right, it's not completely dead geologically. Those bright spots, for example, are thought to be pretty young, maybe only a few 100 million years old.
So even though it's small, Ceres is still alive and kicking, at least geologically.
That's right, which makes it super interesting to keep studying. It's like a world caught between its wild past and its quieter present.
It's wild to think that something so small can have such a dynamic history. And speaking of location, Ceres is smack dab in the middle of the asteroid belt. That's got to be important for understanding the solar system, right?
Oh, absolutely. Ceres' location makes it like a window into the early solar system.
How so?
Well, the asteroid belt is basically a cosmic junkyard full of leftovers from when the planets were forming.
Like a time capsule.
Exactly. And because Ceres is so big and still has so much of its original stuff, including all that ice, it gives us clues about what things were like billions of years ago.
Wow, it's like we're looking back at the birth of the planets.
In a way, yeah. And when we compare Ceres to other things in the asteroid belt, and even to the planets and moons closer to the sun, we can start to piece together the story of how our little corner of the galaxy came to be.
It's amazing how all these pieces fit together.
Yeah.
So after all we've learned about Ceres, what are the biggest mysteries? What are scientists still scratching their heads about?
One of the biggest ones is that subsurface ocean. We've got some pretty good evidence, but we need more data to really confirm if it's there and what it's like.
And how do they plan on getting that data?
There are a bunch of ideas floating around. Some folks want to send another orbiter to get more detailed gravity readings and map the surface even better.
Makes sense. Get a closer look.
And then there are the more ambitious folks who want to send a lander.
A lander on Ceres. That would be incredible.
Imagine getting actual samples of the ice and rock, analyzing those bright spots up close, maybe even searching for signs of life.
Yeah, that would be the ultimate way to know for sure what's going on down there.
Exactly. A lander could tell us once and for all if there's liquid water and what the subsurface is really made of. We could study those organic molecules in more detail and look for any hints that life might be present.
It sounds like we're on the verge of some major discoveries. Ceres has gone from this overlooked object to a key player in our quest to understand, well, everything. It's really exciting.
You said it. Every new thing we learn about Ceres just shows how vast and complex our universe is. It's a testament to human curiosity and our drive to explore.
Well, this has been a fascinating deep dive into the world of Ceres, a world full of surprises and mysteries. It's really changed how I think about the asteroid belt, that's for sure.
It's been a pleasure exploring it with you. Who knows, maybe one day we'll be talking about what it's like to actually stand on the surface of Ceres.
I'd love to see that. Until then, keep looking up and keep exploring.